properties of amino acids, these depend on the R group. What is the R group? Remember, the R group was the variable R group present on next to the central carbon, okay? So this R group determines the chemical properties of the amino acid, and therefore it also determines the properties. So at a physiological pH, amino acids will exist with a net charge of 0 because the pre-existing positive and negative charges balance out. Amino acids are zwitterions. What are zwitterions? Essentially, if you have the central carbon, and remember you had the COOH, and then you also had the R group, then you had the hydrogen, and then you had the NH2. Zwitterions are when this exists in a different state. Essentially, the carboxylic acid is acidic, okay? And the amino group is basic. Acidic things or acids are deprotonated because acids, by the Bronsted-Lowry definition, are proton donors. If they're proton donors, this hydrogen will no longer be there. Okay, here, it's no longer there. And this amino group, if it's basic, by the Bronsted-Lowry definition of bases, this means that this is going to be a proton acceptor, meaning that it can also exist in this form. This has become negative because the hydrogen's been removed, okay, and instead of having 2 pairs, it's going to have 6 pairs and 3 pairs. And then here, you just have gained a hydrogen. So this means that amino acids are amphoteric, which means exists, in both acidic and basic forms. Okay? Next, there's one more thing to discuss. Basically, there is something called the isoionic point, and the isoionic point is the pH at which the concentration of zwitterions is at a maximum. Above the isoionic point, the conjugate base predominates. What does this mean? Basically, if you've got two different pHs, so you've got a pH which is greater than 7, and you've got a pH which is less than 7. 2 different things are going to occur. Basically, at a pH which is greater than 7 first, let's look at that situation. At a pH which is greater than 7, the conditions are more alkali or more basic, okay? And if they're more basic, bases are proton acceptors. If they're proton acceptors, this hydrogen is going to go because the base, the conditions of the solution have accepted the proton, leaving you with a COO minus, okay? And again, the H and the R, okay? And the NH2 stays the same if the pH is above 7. This means that this is a conjugate base. If the pH is below 7, you're in acidic conditions. Acids are proton donors, which means that this is actually going to gain a hydrogen. So you're going to be left with H2N plus, COOH, hydrogen, and R. Okay, and this is in acidic conditions. Isoionic point. At a pH above the isoionic point, the conjugate base predominates. We understood that. We know that because if it's above the isoionic point, it means it's more basic. If it's more basic, bases are proton acceptors, meaning you're going to lose a hydrogen. Here, acidic, you're going to be donating a proton, NH3.